So I'm going to get right into it, Grant. Why do people love prime numbers so much? I talk to people who are interested in math, and you start talking to them about prime numbers, and it's like a kid watching an airplane take off for the first time over and over and over again. What's going on there?
Well, they're deeply fundamental. So, in the same way that atoms build up all of the molecules in the world, you have this sense that when you're studying numbers, just counting numbers multiplicatively, like these are the fundamental building blocks. And often, when you're solving a problem, breaking it down in terms of primes, if you're doing something multiplicative, that's like the first step. And yet, despite them being so fundamental and one of the first things you'd ask about, there's just this pile of unanswered questions about them. And it's one of the few places where it doesn't take too much digging before you find yourself at the forefront of what people even know. So just to list like a handful of famous conjecture in this direction, you've got the twin prime conjecture. Are there infinitely many that are just two apart? The Goldbach conjecture. Can you always express an even number as the sum of two prime numbers? Are there infinitely many what are called like Mersenne primes that look like 2 to some power minus 1? Just a lot of things in this vein. And more often than not, what you'll find is these unsolved questions come when you ask additive questions about primes. So like twin prime, are they two apart? You're asking an additive question about a multiplicative structure. And that mixture seems to be this perfect recipe for just injecting math right into that realm that we have no idea how to answer it. Even though like a lot of good work has been done on these sorts of questions, even just like within the last decade or two. But yeah, so not to rant too much, but I was definitely one of those people that like as a kid first heard twin prime conjecture, was immediately captivated, right? And you have that little light bulb that goes off that is born from a mixture of curiosity and naivety, which is like, ooh, what if I could be one to like make progress on such a thing?
Hmm.
Um, and I think a lot of mathematicians in their youth like have that kind of relationship with, if not prime numbers, other kinds of questions like the hailstone conjecture or such that are easy to phrase but turn out to be very hard to solve.
So I want to go down that rabbit hole of as a kid, because you said something interesting there. What was or what were the moments that got you inspired to be into math? And what you said there was is sort of where I want to point at this question. You said, if I could make progress. But I see you much more as like a Carl Sagan, of like somebody who is translating the world of math to millions of people on YouTube. And you've probably done more in furthering my granted limited understanding of math than anyone else that I follow. And so how much do you see yourself as sort of what was implied by that answer of expanding the frontier versus making the frontier that already exists legible to a certain set of people in the world?
Oh, yeah, to be clear, I'm not a researcher. And at some point, kind of, if I like look back at my path, it sort of switched gears in the direction of exactly what you phrased pretty well there, which is trying to find different perspectives on things that are known rather than trying to like forge into things that are unknown. Um, I don't know, we can drill into like why I didn't necessarily go into
Yeah, let's do
research.
that.
But I don't know if I have a great answer. I can like speculate around it, but maybe there was another part of your question there, which is just why I fell in love with the subject to begin with.
Yeah.
And those might actually end up being kind of related because, um, the pure reasons to give would be something like, oh, I just saw the beauty of like numbers and these patterns and like fell in love. Really, and I think this is probably true of a lot of people. There's probably a lot more ego than that because, especially when you're like a young male, there's a little bit more focus on like yourself and whether you're at the top of things than at other points in life or other demographics out there. So, like my dad played a lot of math games with me when I was like very little, and he clearly wanted both his sons to be like curious people, as a lot of fathers do. And I think that just sort of got into this positive feedback loop where at some point, pretty young, I like self-identified as being good at math. And then when you self-identify that way, you like it. And then when you like it, you spend more ambient time just like in the back of your mind staring into space thinking about it. And like that really gets this flywheel rolling. And it probably wasn't until like high school that I had a love of math that was pure in a sense of just like loving the beauty of it and letting myself get engaged with it that way in all of the ways that like nowadays I try to promote and get other people into. Um, but I think if I look at like my undergrad time, Yeah, I've said this in other outlets before, but probably my biggest regret is not having engaged more heavily with like the researchers and professors and
Hmm.
mathematicians that I had access to, for no good reason other than like shyness, I guess, mixed with maybe feeling a little bit more warm towards the computer science department than the math department, despite the fact that I was like studying math. And I think honestly, if I had been a little bit more engaged there, it would have been more likely that I like got pulled into like a traditional research route. But at the same time, I don't know that like I don't. You clearly do things on the internet, and you've got like this podcast, and you've got this kind of personal life investment in the idea of stuff broadcast over the internet. There was a part of me that just had this feeling that academia over the next like couple decades felt like a less stable life bet
Mm.
than trying to establish some kind of footprint on the internet. And also just the things that bring me the most joy usually take the form of new perspective on known things rather than that sense of like being in this totally black room where you're not entirely sure what's going on and it's not even clear if things ever will become clear. And that might just be a personality quirk.
Yeah, there was a quote that you give in your TED Talk, and it is: the mathematician does not study pure mathematics because it is useful. He studies it because he delights in it, and he delights in it because it is beautiful. And I think that speaks to a lot of what you've been saying here. And the question that I have for you is, how much do you think of math as like a closed system in itself that has this internal beauty versus something that is beautiful because of its explanatory power and because it has its boots on the ground with reality?
Personally, I like it much more when it is clear where those boots are. And over time, I think I've been getting increasingly fed up with math that doesn't even try to uh, draw that connection to reality, mainly because if you have a desired application, or at least the threshold of we need to be related to another field that's not math in order to take it seriously, then you can't move the goalposts and you can't just have a paper that says, here's something that we're pursuing simply because a Fields medalist once asked the question. And when you can't move the goalposts, it forces you to innovate. Whereas if you're just kind of leaning back on the idea of, oh, well, it's intrinsically interesting and something, something beauty, something, something not theory, then there's no clarity on whether what you did required pushing yourself to innovate rather than just taking what was readily findable based on like intuitions that you already had and results that were already uh, like primed to be built upon. Um, and honestly, I do think there's different categories of mathematicians here where you have some that honestly do not care about application,
Hmm.
um, either because they just love the idea of pure abstraction as a powerful thought mechanism, like people who get really into category theory without any care for application, though a lot of category theorists do care, to be clear. Um, and then you have some that just love puzzles, like combinatorists, I think probably disproportionately fall into this category of those who just love puzzles and the kind of puzzles that math brings about, and it doesn't really care if it's touching the world. But there's just a wide swath, especially those who came at it through physics, who think of math as a tool, and like the reason that it's beautiful is because of its the Eugene Wigner unreasonable effectiveness that it provides. And I think the more that time goes on, the more I fall into that latter category of really really needing to see maybe not a direct connection, but it's some semblance of a path towards the real world before I'm comfortable describing something um, as worthy, as beautiful, as uh, uh, like good high quality math.
One of the things that I've been grappling with and actually struggling with is, what is the role of studying things for the sake of studying them in my life? And one of my biggest concerns, now that I'm living with a mathematician, which is awesome, because I'm realizing that there's a whole, it's almost as if I didn't see the color blue until 15 days ago when we moved in together. It was like, you know, looking at the world and you see something new, and it's like, wait, I don't actually have that language, have those models in my head to be able to try to understand reality. And I've had a lot of these same conversations around philosophy of trying to get into the lineage of Western thought, but there's something about it that doesn't have that practicality to it. And so, as you study math, how do you think about the trade off between studying math for the sake of just studying it because it's beautiful, because you want to learn it, and then how much of your study of it is in direct pursuit of a video or a problem that you're actively grappling with?
Well, I think you hit the nail on the head with the very last part there. These days, almost entirely, I'm viewing things through the lens of, can I use this either in a video or in something expository that is hopefully just enjoyable to consume for someone else? And there's a couple of reasons something might be enjoyable to consume. A lot of times it's because of that application, it's physically relevant. But there are times when just the pure story in and of itself, like prime number puzzles, are a great example of this that you opened with. There's something intrinsically fascinating, does not need any more direct motivation beyond that. If anything, it's always kind of awkward whenever people are talking about prime numbers, and like almost as an obligatory thing in the footnote of their article, they're like, by the way, prime numbers are used for cryptography without like much more of an explanation than that. And it's this desperate grappling hook that number theorists have on like the utility of their subject. But that doesn't at all capture why they're interested in it. Almost no one is interested in primes because of their application of cryptography. The thing that hooks them is this bizarre thing that's going on with, why is something that's so simple to describe so hard to draw conclusions about? And I just think of these as two different categories of videos, of expository possibilities. But everything that I like think about these days ends up going through that lens. So it's not an either or. And one thing that I'll often lean on if I'm trying to, I don't know, put some sort of conclusion at the end of a video that is a little bit more like inside the internal bubble of math without application, is to emphasize that the kind of problem-solving abilities and patterns that you're coming to recognize, and all of these intuitions being built through the pure puzzles, very often become relevant just as a set of problem-solving muscles. So even if you're sitting back and you're like, when am I ever going to use this? And there's not a direct answer to the this of this topic and video, solving some IMO problem or something like that. You have to acknowledge that the people who do solve these things, like those who did math Olympiads when they were in high school, or like did the Putnam type stuff when they were in college, there's just this high correlation between them and people who do useful technical things for society later on. And like, that's obviously not a coincidence. And it's not because they're applying like the weird esoteric problems of the IMO in their real life. Like usually there's no direct application, but there's some kind of deep-seated set of abstractions for what patterns we recognize, what problem-solving tactics we've been exposed to and like built the muscles for, that is hard to articulate, but nevertheless very worth thinking about and valuing and using as a justification to spend that afternoon thinking about a puzzle that has no earthly bearing on physical reality.
Yeah, I want to sort of follow this little theme, and I'm going to call it the usefulness of useless knowledge.
Mm.
And I see the same thing with philosophy and physics. So it's as if they touch some substrate of reality that isn't directly applicable immediately. And I've seen programs, especially in philosophy, they're like practical philosophy programs. And what's really interesting is the second that you add that word practical, you kind of destroy the
Mm.
thing that made philosophy great. And so it's almost like there is a usefulness over certain time horizons, that maybe learning a certain idea that most people would consider useful is thinking about useful in terms of it'll be useful in the next weeks or the next month. But I think that what you're trying to get at here is a usefulness of a lifetime and a usefulness of finding either meaning in your life or being able to have a lens on the world that most people don't have because they didn't have the time horizon to study some of these things.
Yeah, I mean, one great example of that with philosophy, it seems like business leaders in Silicon Valley are heavily overrepresented
Yes.
as philosophy grads, and that you just have to acknowledge that there's something going on there. And in much the same way that pure math enthusiasts end up heavily overrepresented in like computer science and stuff that's like heavily applied, even if that might not be the reasons they got into it. I think one of the things that's happening here, um, I mean, I guess I used the phrase before, but just like pattern recognition, straight up pattern recognition, where there's phenomena that happen in the world that don't necessarily have words to them, but like if you have a really good sense for convexity, let's say,
Yeah.
like you thought about the difference of squares and like the strange idea that, when you um, multiply two numbers that are like equally distant around some midpoint, the product of them is a little bit less than the square of that midpoint, and like that as a loose, hard to articulate pattern, like comes up in so many different ways. And maybe in a computer science landscape, it looks like convex optimization, or maybe it looks like understanding like geometry of complex numbers in a certain way that then gets applied to like electrical engineering, like all sorts of just little nuggets that happen when you really let yourself meditate on like a raw pattern in and of itself. That's one thing. And then the other is, I think there's like a social component here
Hmm.
where the kinds of people who are comfortable nerding out about particular kinds of math and puzzles then get drawn to each other. And then, when people are together, then they exchange thoughts on all sorts of other things. And that level of collaborative socializing might not just be amplifying what pure puzzles they're talking about, but also, oh, like I've been dealing with this like new programming problem. Do you want to like help me think about it? Or in the context of people who are into philosophy, they get together and have this long dinner chat over the Hegelian dialectic. But
Hmm.
then, as like a side product, having brought together all these like minds, they find themselves chatting about something that's more like
Right.
directly useful. And so, almost just as a common social thread to bring certain kinds of minds together, and then once they are together, that's a net productive thing. That seems to be a big part of what lies behind these like correlations between the philosophers and the Silicon Valley CEOs and the mathematicians and the programmers.
Yeah, I think that there's a lot of truth to that in terms of especially the Silicon Valley CEOs. That's something that I've always been very interested in. I mean, one of my theories here is that a lot of these people just would have been academics, and then
Mm.
the actual money and the intellectual joy of solving a lot of these problems and just the profitability of it took a lot of those people, like Paul Graham comes to mind, outside of the world of academia and maybe brought them into the world of entrepreneurship. But one of the questions that I wanted to ask you was, you mentioned the two primes conjecture, and we've made progress on that, say, in the last 15 years. There was a major development with Fermat's last theorem in the 1990s. In what sense do you think that there's stagnation in math, or do you see an exponential improvement? How do you try to deal with that question?
I mean, it would be pretty hard to take the stance that there's not an accelerating rate of progress. I've heard some like cynics in that direction, and it's such you almost want to take it because it's this delightfully contrarian thing, like, oh, we've invested 10 times as much, but we're not making any more progress. But it just doesn't bear out. Certainly, if you're measuring it in terms of papers published, then yeah, you've got this like exponential increase. But a lot of papers might be frivolous, and it might not actually be making progress in the right ways. But I think even in the right ways, like, I mean, one of the most important questions you can ask in math that maybe not enough people ask is, what should the axioms be?
Hmm.
Like, it's not just a pursuit of what theorems are true given some set of axioms that we start with, but stepping back and saying, what is the right framework to even be viewing all of this? Um, and I mean, one of the biggest things that characterizes math in the last century, as differentiated from those in prior centuries, is viewing it through like a lens of categories and
Hmm.
very like top down in abstraction, as opposed to through the lens of, it's not directly opposite. You can have categories and sets, but oftentimes like either you're thinking of a certain construct in terms of a set theoretic way, like how do you build it bottom up, versus category theoretic, which is much more leaning on an object is defined by its relationship with other things. Now that's not exactly like this concrete, oh, you're going to touch the world in a certain way result. It's not exactly something that is like this named theorem per se. It's more just like this general perspective that's moved its way in. And there seems to be a lot of thoughts like that where people are asking deeper questions rather than just how do I get to like some new theorem so that I can publish as many papers as possible. Though to be clear, that like is happening. Um, and also just like in terms of looking at a scoreboard on um, like how many unsolved problems are getting solved. Uh, there was this famous address that Hilbert gave in 1900, sort of at the turn of the century, laying out a bunch of problems that he saw as like particularly important. And a lot of them were like maybe ill-posed and not exact. But if you just look through like how many of those were solved in the last century, I think it's fair to say we're doing pretty well. There remain ones that aren't answered. Things like, the Riemann hypothesis is maybe the big one. Um, but an echoing of Hilbert's problems came in 2000 with the Clay Math Institute, putting out $1 million prizes for 7 specific unsolved problems. And on the one hand, only 1 out of the 7 has been solved so far. On the other hand, like, hey, 1 out of 7, that ain't bad, given that we're just at the very beginning of this century, and they were listed as like the Millennium problems. And they're just like, very famously hard. And a lot of the partial progress made towards them, that's what actually matters. Like, no one cares if there's two infinitely many primes that are 2 apart. That's never going to make a cryptographic algorithm more secure or anything like that. But because it necessitates creating new ideas and new math in order to even attack it, it's, I think, highly likely that whatever did solve that would find itself application elsewhere. So all of the partial progress being made towards these kinds of unsolved problems, that's sort of where the meat is. And yeah, I just, there is that part of me that wishes I could stand and give a good justified contrarian view that like, oh, math is slowing down when you need to like accelerate the progress engine again, but it just doesn't bear out.
Good. I'm happy to hear that. You mentioned the axioms earlier on. Is there anything in math that's sort of like physics, where you have Newtonian physics and you have Einsteinian physics, and they're both axiomatic, but they don't quite square up? And it's like there's something in the foundation of mathematics that is nagging the field.
Oh, well, are you familiar with Gödel's theorem?
No, bring it on.
Oh, great. Okay, so great. One of the kind of ill-posed things that Hilbert set out in this 1900 speech was like giving a rigorous foundation to math, like finding the right axioms where, let's just say we're talking about facts about numbers. You want some axiom system that will describe numbers such that anything that's true about numbers is provable, right? You could use those axioms, you could use first-order logic, you could just like go and prove something that's true about the numbers. And that every truth is accessible in this way, and that it's internally consistent, that you can't prove false things. Seems reasonable. That feels like what math should do. It's like, yes, anything that's true, we should be able to prove it. We shouldn't have inconsistencies. People like worked on this. One such young lad who worked on this particularly hard was Kurt Gödel. And I think, oh God, I'm going to get the timeline wrong. But, a decade or two after this is kind of like posed, Gödel comes out and is like, turns out not possible. You're like, I'm sorry, what? It's like any axiom system that you have, there's going to be a true fact about numbers that it cannot prove, or it's inconsistent. It's like, well, that's unsettling, that whatever foundation we have, there exists a truth, something that we know will be true about numbers, but it can't be proven. And so it's just this like Red Queen game of which, if you shift your axiom systems in another way, then there's going to be another fact that's true, but you can't prove it. And for a while, it seemed like, okay, yeah, but the way that Gödel discovered this stuff, it was this very self-referential thing, where you start with, how when you say a statement like, this statement is a lie, and then you think about it, and you're like, is that statement true? Well, if it's true, it's not. If it is, if it's not, then it is. But that's language. That's not like rigorous math. Essentially, what Gödel did was he took that self-referential idea of saying this statement is a lie, but you say it using numbers in this like particularly clever way. So it ends up being something where you say like, this theorem can be proven with these axioms, but the way that you say it is like with a number. And so it's very clever, but it doesn't feel like the sort of thing you would naturally be asking about. It's not a twin prime conjecture type thing. It's a statement that was designed to be improvable. But then a little bit later, there was this theorem called the Paris-Harrington conjecture theorem, something like that. And it basically was a question that, I don't know if it's the most natural thing in the world, but it came out not because we were trying to come up with a self-referential thing that had this paradoxical nature, just a question about like discrete math. And it turned out to have the same property. That it was like it could not be proven within like the scope of certain axioms. And it was like a naturally arising example of the sort of things that Gödel's theorem said must exist among any. So that just shook the foundations of math for people even thinking that it was possible to have like the correct axiom system. And from my view, it kind of doesn't matter. Like, I don't actually think that, I think one of the biggest misconceptions about math is that it's about absolute truths, and it's not.
Hmm.
Uh, like, what it actually is a means of connecting assumptions with results. And certainly anytime you are trying to apply it, you feel this very viscerally because you're like, ah, well, we're doing these statistics, and according to a normal distribution, such and such should be like very unlikely. And you say, well, normal distribution, central limit theorem assumes that your things were independent. Were they independent? And you're like, oh, we've got to question the assumptions. There's always this like this question of like, were the assumptions correct in the way that we applied it? And the idea that that ends up cutting in a parallel way down to the core of pure math itself, where the results are dependent on the axioms that you chose, and you never have something that is a pure capital T truth. It's
Mm-hmm.
always a path. That I mean that feels more honest to me, and that feels good that it mirrors the way that math ends up getting applied, rather than being some completely separate type of reasoning that happens in the pure land versus in the applied land.
How about progress in terms of our ability to teach math? So, this is, of course, something that you've been very much involved with for years, even before you really started the YouTube channel, working at Khan Academy and looking at how do we train people to understand math. And I think that the number of people, such as myself, who don't understand math as well as they should is way too high. And I worry that in math, with math in particular, that if we make fundamental new discoveries, say in rockets, we can all sit back, whether it's on Twitter or whether it's on TV, and we can watch a rocket soar off planet Earth and then land right where it took off. And it's amazing. We can see the fire, we can see the fuel, we can see the smoke and the flames, and it's grand and it's magnificent. And my concern with math is like there's such a small percentage of the people on planet Earth who can even appreciate what's going on at the frontier of math. And that in some way that's hurting our ability to be inspired by the beauty of numbers.
So a couple things there. If it's bad, let's just agree that it's better than it ever has been before. Like the ability for people to get back into math, or the resources that students have available to them, or our knowledge about what it takes for people to learn. It's definitely way better than it has been before. And I think this is reflected in the fact that we have many more math literates these days than even like 50 years ago. Even if it's not universal, that's like a fact. One thing that I find quite interesting, sitting here in like the land of YouTube and popularizing various different scientific subjects in YouTube, is to look at Brady Haran. Are you familiar with him?
I have come across him, but I haven't watched any of his videos.
Great. So he runs a number of channels. One of them is called Numberphile. It's
Right.
about math. It's the biggest math channel.
Australian guy?
Australian guy, yeah. He like has a background in journalism at the BBC. But he's just got like a bunch of channels in various different subjects. So like periodic videos talking about chemistry, and some that are talking about like physics, some that are talking about computer science. Just really running the gamut on like different topics in the same style, which is to interview experts and then to provide a good like production quality surrounding that interview. And it's good stuff. Now, if you had asked me, 10 years ago, let's say Brady's like starting these projects, and you say, place your bets. Which of these channels will be the most popular that most people want to watch? And I think like, well, definitely the physics one. People seem into that.
Mm-hmm.
That's more tangible. Same things with like things like chemistry or computer science. The one about numbers and math, like, I don't know, maybe that'll be one of those backwater ones that is just for a specific esoteric audience. In reality, Numberphile is the most popular by far. And maybe that's just because the particular people that he chose to interview in the early days of Numberphile, just by happenstance, are much more engaging than the ones that he happened to interview elsewhere. But I think that actually reflects a kind of unappreciated universality to math appeal, where you have people who are interested in it, and just in an entertainment kind of way, just wanting to ambiently learn about it by choice as they're scrolling around YouTube, from a lot of different backgrounds for a lot of different reasons. Maybe it's students, maybe it's engineering nerds, maybe it's like science nerds, um, maybe it's people who they're not even into either of those, but they just love patterns and Sudoku type puzzles and whatnot. Like you have all these different avenues that make people interested in the subject in a way that I just really like the Brady Heron example because it's so viscerally visible how much more popular like the math version of this style ends up being
Hmm.
than another ones. And that gives me a lot of hope for what the, I don't know, just what the general public interest in this circle of things is. Granted, I think it could be a lot more, and I think we could hope to see 50 years from now just an exponential increase in the number of people who are inspired in progress in that the same way that you just described rockets. Um, but I think there's every reason to believe we're on that trajectory and that it'll continue to grow because through things like Khan Academy or Brilliant or all sorts of organizations out there that are aiming at having like scalable quality learning accessible to whoever wants it to be there. It's just better than it ever like has been before.
Yeah, I'm surprised you didn't mention pop culture because I think that that's one of the elements here, and I think that this is something that you very intimately understand of how a story and conflict and this need to know how you sort of create a question in your viewer's mind and then you get to a place where the viewer's like, I need to know this because I'm sure that you think about, oh my goodness, somebody could go watch another YouTube channel at any point. And what I love about your channel is I, I guess this is going to sound crass, but I mean this in the best way. Like, you're kind of just a middle finger to all the people who are like, you know what? People have shorter and shorter attention spans. They're not willing to deal with high level content. You are proving every single day in your life that that's just not true. And I think of something like The Three Body Problem, a
Mm.
Chinese science fiction novel that is based off of a super simple but super confusing and absolutely wild mathematical idea.
That's a great example. I'm right there with you on this narrative that people have shorter attention spans being kind of BS. I do think that yeah, in some avenues this plays out. This is probably why short form media like TikTok can be very addictive in a way that other things aren't. But like Netflix is typically quite long form,
Hmm.
especially if you consider that series are a longer form than movies themselves, even if they come in more, excuse me, more bite-sized chunks.
Right.
Um, and if you look at YouTube 10 years ago versus YouTube today, the average video length is much longer. There's much more incentive around long videos, and I think that's because it's recognized that that's typically what a better user experience is. More often than not, when a video creator makes the claim that people have short attention spans and you got to keep it shorter, it's because they don't want to make a long video. Like videos take a lot of time, and like you're sitting there on minute 5, you're like, boy, I wish I could wrap this thing up. If I had to go for another 25 minutes with this level of production quality, like that's just going to eat up my month. Um, but the ones who I think succeed the most are the ones where there's real depth to the explanation. Another, if we're just going to point to like successes of math on YouTube here, I think another nice one is Vsauce, who has videos on a number of things, but he's got a ton on math, and they're extremely popular. And I think maybe I was looking at it the other day. It's like the third most popular video on his whole channel, and this is hands down one of the biggest like education channel in existence. The third most popular is about the Banach-Tarski paradox,
Hmm.
which is a deep and not easy to explain concept in very pure math, which is an idea of how if you take a sphere, like a solid ball, you can subdivide it into 5 different pieces, such that when you rearrange those pieces, you get 2 perfect copies of the same ball, which seems to violate very basic things like a conservation of mass, for example. Um, but quickly realize this is because we're talking about like a very pure mathematical sphere that's not made of atoms, but it's made of this uncountable infinity of like of points, of just triplets of numbers in space, and how this discrepancy between modeling something as a continuum versus modeling it as like atomic allows for this very counterintuitive thing that you can subdivide into 5 pieces, rearrange those 5 pieces, and get 2 identical copies of the original thing. So actually explaining that is quite hard. Like it's if you did it the naive way, you have to like give people this background and these things called freely generated groups and whatnot. Actually explaining it in a way that's substantive but doesn't require all of that is even harder. He does a great job, and it's like 30 million people out there are the wiser for it because it's just this high quality explanation of a very real topic, and I think it satisfied a hunger that people have to actually get the real explanation. Don't just give me this high level divide things, get two copies of the original. Like, I'm here, I'm waiting. I've got 30 minutes to spare. Like, explain exactly what's going on there. Like, people are hungry for that, and I think the video creators are rewarded when they put in the effort to satiate that hunger.
You're talking here about a kind of problem solving that you do where you have a starting line of this is an interesting idea that people need to know about and that I want to spend, say, the next 2 weeks to 2 months of my life studying and explaining to people. And
Mhm.
then you have an end goal of I need to figure out how to create a story that's both engaging, compelling, and that's going to hook a reader or a viewer in, and that's going to basically create an image in their brain after they watch the video that they will remember what they've seen. So that's the challenge here. And a couple months ago, you gave some problem solving tricks. You shared 9 of them, and 2 of them stuck out to me. The first was leveraging symmetry, and the second one was give meaningful names. Why are those important?
I guess for very different reasons. So, starting with the second one, giving meaningful names. Um, I cannot remember whose quote this is. Maybe you can help me, but it's like perhaps the organization of one's thoughts is not distinct from the content of those thoughts. And that really strikes me as something that's kind of deep, where we think of those as separate things, but the mere act of organizing might be the substance of our thoughts. Like that, there's nothing more than that. It's just good organization. And so naming is
Wow.
the first step to that. It really highlights what parts of a problem or a diagram or a set of algebraic quantities are worth highlighting. And when you're asked to name them, it's kind of this forcing function to say, what is meaningful about it? Like, what is this part of the geometry problem that I'm dealing with? Or what is this right-hand side of the equation representing? All of that. Um, so that it's just, it like clarifies thoughts the same way that writing does, when you're forced to write an essay or write a journal entry as opposed to letting it stew around in your own head, something different happens through the articulation. On the symmetry front, that feels like a very deep question where I honestly don't know how to answer that. It's almost bizarre how when you look for something about a problem that doesn't change when you shift it in some way. So symmetry is most visible in geometry, but we're not just talking about something geometric. But like if you're looking at a geometric diagram and you say, "Wow, it looks the same or it has similar properties," if I look at it from two different perspectives, that lets you create things like equalities because maybe an aspect of it viewed through one lens is non-trivially the same as that same aspect like viewed through another lens. Um, and that as soon as you're starting to connect things, that gets you the progress towards whatever you're trying to solve. I mean, like the Pythagorean theorem or something like that, where you want to say that a squared plus b squared is the same as c squared. Like you need to draw an equality in order to do that. Like finding two perspectives of the same thing is kind of how that happens. But I mean, there's all sorts of things that are even deeper than that. It's like in differential equations, often you have these results around how if you have a symmetry to your setup, then you can reduce the degree of the equation for each one of those symmetries and such. Or the way that groups are connected to physics, you kind of have this, it's what's known as Noether's theorem that says that every symmetry to the laws of physics corresponds to a conservation law.
Hmm.
So like if the laws of physics should be the same, whether you're here or 2 inches to the right or 5 light years to the right, like wherever you are spatially translated, the laws of physics should be the same. That ends up implying that there should be a kind of conservation of momentum. And like rotational symmetry implies that there should be a conservation of angular momentum. And in fact, every kind of symmetry corresponds to some kind of conservation. And anyone who's done any level of physics knows that conservation laws are like how you solve problems. So that's a particularly deep connection there. And I don't know if there's a good answer for like why that principle works as well as it does, but it's worth underlining.
Yeah. I don't know if this is relevant or not, but I'm going to give a very biblical answer to they gave meaningful names. It's probably not a coincidence that in the book of Genesis, God is tasked with naming things. That to name something is to give people power. I mean, can you imagine? And it is to create the nature of that thing often. I don't know if you've ever suffered from naming something and having other people adopt it and then actually not liking the name of what you named the idea. It's happened to me a couple times as I've taught my writing students, and you can't change the name. The name itself is so deeply intertwined with the idea, and there's something there that how you name something, just like what you said, how the organization and the content are so intimately linked. I think that once you name a thing, you're giving structure to that, and there's this whole set of assumptions that are given when you take that action.
Yeah, yeah, it's almost like if someone was dumb enough to name their YouTube channel after a piece of their
Eye
physical
color.
anatomy. You can't change that, no matter how uh, weirdly self-centered it seems in hindsight.
That's very funny. What do you think of the trade off between productivity and distraction? And I am here, like, we usually see distraction as something that is bad, but it has actually been our friend Michael Nielsen who has changed my mind on this. He quotes Freeman Dyson talking about Robert Oppenheimer, who says, "We can see the nature of the flaw which made his life ultimately tragic. His flaw was restlessness, an inborn inability to be idle. Intervals of idleness are probably essential to creative work on the highest level. Shakespeare, we are told, was habitually idle between plays. Oppenheimer was hardly ever idle." What do
Hmm.
you see as the role of idleness in your work?
Oh, it seems very important, but that sounds like a rationalization. I mean, I think it's worth being very conscious of the role that each play, because what you just said really resonates with me, that you actually need distraction to stumble upon like new insights. Like have that comfort in just reading a book during the workday that you otherwise might not be reading, or letting yourself just noodle on a piece of paper or something. But it can't just be any distraction, right? If you're like off playing Candy Crush, I don't think there's any way to justify that that's um, promoting creativity. But the right kinds of idleness and distraction that are not purposeful towards a given plan, I think that's very important. But at the same time, at some point, you got to sit down and just get the thing done.
Gotta get it
And
done.
usually, the hardest part of that process is the part when you're going to be most inclined to find yourself distracted. Uh, it's you're trying to solve some little micro puzzle. You're dealing with just like a really annoying sound editing task or whatever it is, and you're like, yeah, maybe I kind of want to go read. Like those are the moments that maybe distraction isn't the highfalutin creative inducing thing that you want it to be, and actually what it is purely slowing you down. Um, another mutual friend of ours, like Andy Matuszczak, I think I remember him asking about this dichotomy between, like, let's say you're trying to write something, whether you should be like going for a long walk and just sort of like letting things stew versus just like gluing your butt to a chair and like typing and just not stopping. And he was asking this on Twitter, and someone gave what I thought was just an absolutely great response. There was something to the effect of, what you're asking about is, should I be exhaling or should I be inhaling?
Hmm.
The question is not any one of them. It's like this finding the right balance between the two. So in that way, I think idleness is like inhaling, and then just gluing yourself to the computer and getting stuff done is the exhaling. And it's important to recognize when each one is needed.
Yeah, I don't really know, but I really like your point there about how new ideas do come in a state of distraction. And I'm almost wondering if productivity is sort of optimizing the system that you already know exists, whereas distraction is almost like an algorithm for randomness, where it just on average or your median insight or moment will be basically inconsequential, but for the small percentage of things that are consequential, they are the only things that can take you out of the matrix that you're locked inside of.
Easily, yeah, the best projects I've ever had came from were born in distraction, not in purposeful planning. That's absolutely true.
You have a template for your work, and all your videos build upon some kind of template. You must have spent a long time investing in that template. How did you create that template, and what was the thought pattern behind doing so? Was it all like a one big fell swoop where you're just going to create it and then you're going to use it forever, or what was behind that?
Do I have a template? I don't know if I've ever like thought about things. You mean in terms of like narrative construction or in terms of visuals or
Visuals, like the little pie
yeah.
with the eyes,
Oh
stuff like
yeah,
that.
yeah. Okay, so I guess in that way, like, the way I do animations is a little weird. It's all programmatic, and what that will sometimes mean is um, it's nice to leverage abstraction, where if you've just got like a scene type that you just have to like tweak some attributes for, that's just way easier than doing it ground up. So in that way, like a default scene is the sort of teacher-student thing where you've got the three blue pie creatures and the one brown one. That's just, yeah, that's because it's like sitting right there as a scaffold, just waiting to be filled in with content. And I think that doesn't have to come from weird programmatic animation. A lot of people have assets set up like that, but it'll also mean that during a particular project, I might like set the infrastructure for the kind of thing that I want to animate. Let's say it's like the Fourier transform, and you've got a particular visual that the whole video is meant to center around. So you've got infrastructure for it, and then everything is like a variant of that core visual type. Um, and I think a nice side effect of that is that it gives a certain like stylistic consistency, and then you can connect ideas through visual similarity. This thing that we're looking at now visually looks like this thing we were looking at 10 minutes ago, and through that, the viewer's brain can hopefully like see a connection more readily than if it was more stylistically inconsistent. But I don't actually think I've been very deliberate about establishing a template and thinking what the best template is. That's more an emergent phenomenon than
Hmm.
anything deliberate.
Do you think about building a brand at all?
Kind of, yeah. I mean, I do think brand is very important for just like anyone, really. Like that's one of those aspects of how you run. It feels weird to call it a business, but any kind of like business or something with public presence, I think it's important to think, what is the emotion that this evokes when people see a few key triggers?
And what
That's
do you
really what
want?
a brand is. Well, I want like people to trust that they will come out understanding something and having a good experience. Like the hope is that if someone sees a thumbnail for like a video that I do, that they have this like they're willing to do a trust fall and they like fall back into it with the next 20 minutes of their life, and that I can like hopefully deliver what was like a meaningful experience there. Um, that that it won't be shallow, I guess. That if there's a claim that something will be explained, that uh, I don't know if I always follow through on this, but the goal is that someone doesn't think that it'll just be like a high level surface thing that they would have been able to find elsewhere. Like all of that gets built in, and then in order to maintain that, like stylistic consistency is the other like component of branding, where whether that means just like having a logo that doesn't change too much, or having like visual schematics that identify like this channel as something different from other channels. And everyone has this, like everyone has their like notion of branding, whether it was deliberate or not. Um, and I think it does matter for getting this immediate mindset from the viewer that you want them to be in as they're starting their experience.
When it comes to videos that you create, what in math do you find to be particularly hard? Is there a subsection that is easy to other people, but somehow just and agonizing to you?
I always have a hard time putting together a video about probability, and I actually don't know why. It's not because the material is harder per se. Um, I think it's just that there's like so many different ways that people seem to be coming at it from, and like different priors that people have, or different like constructs that would be more helpful to them. And there's other topics where I think, okay, this way of viewing it pretty universally, I think people will like. Um, I always have the hardest time if I'm putting together a script on something about probability, thinking like, should I say it this way? Well, someone might prefer to see it that way. Well, it kind of depends on if they're thinking of it as someone coming in from machine learning, or if they're coming in from physics, or are they just thinking of like counting problems. Like it always that it always has this uncomfortable multiplicity. So even if the subject matter isn't like deeply challenging, expositorily, it's actually for me like very challenging. Which is why I make so many promises that I don't follow through on with respect to certain probability videos.
You were talking about the experience that your viewer is going to have and how with probability it's hard because people come at the video from such a medley of perspectives. And that leads me into my question. Do you consciously get feedback? Do you have a process of getting feedback from the YouTube comments? Do you have a process from before you publish a video? Like you send videos to people? How do you actually develop that intuition that is so easy for a teacher who's just speaking to an audience in a classroom? You can tell when Jane in the back is bored or Billy in the front is enthralled with what you're saying. How do you build that intuition if you're creating digitally?
Even for the teacher, I think it's hard because unless you're doing something one-on-one, it's hard to know. Let's say you can tell that a student's bored. It's hard to know why.
Mm.
It might have nothing to do with your lesson. It might be because they didn't get enough sleep. Or if it has something to do with your lesson, you don't know what. So I think one-on-one, either conversations or sample lessons in the ideation phase are important. I always, yeah, I always feel good when I do that. The less I do it, I just do it more. However much I'm doing like sample lessons preceding a video, it's not enough, I think.
So, what are those sample lessons like? Are they in person? Are they virtual? Talk about those.
In person if possible. These days, that's harder. But even still, like at the loosest, it can be if you're just like chatting on the phone with someone, though it's harder without visual cues. But yeah, I've had times when I'll just have like a very basic overhead camera thing to do it virtually and like scribble something. Um, but uh, what you want is to kind of explain something and then get an instinct for what excites the person, what confuses them, um, what perspectives resonated most, and just like really uh, iterate based on that. Like I said,
Wow.
I
That's,
don't think I do it enough, but
this is really interesting. I think you're surprised by how I'm surprised by this, but I expected the answer to be no. But it's interesting because when I teach my writing students, we have an acronym called CRIPS. And so in all moments of feedback, everyone looks for things that are confusing, repeated, insightful, boring, and surprising. And
hmm,
you said two of those, and it just makes me think that there's something fundamental about the things that you're looking for when you're trying to teach. So, what you're doing when you say overhead, what is like the ideal scenario that you're doing like a 20-minute explanation? And what do you mean by overhead?
I meant that much more uh, uh, menially than I think you thought. Just overhead camera while I'm doing a video call, that kind of thing, so that you can write down. Um, but yeah, because so merely because having things that are drawn and written is much better than waving your hands in the air and asking someone to imagine.
Yeah, one of my dreams, and someone's going to invent this, it will be invented before I die, is I would love somebody to invent a ability to map things out in 3D as you explain things, because I'm very handsy when I talk because I try to sort of visualize these sort of three-dimensional construction. And a lot of this idea is inspired by Brett Victor, who I'm sure you know, and trying to visualize these ideas. And leads me into a next question. What do you think that you've taken from Brett?
That's a good question. I mean, there's something to be said for unabashed optimism and like engaging with what a future should look like and feeling uncomfortable with the norm. Like almost in even if that's not something that is directly applied to the same fields that he's talking about, if it's interaction with computers and software, just the idea that the way that things are currently done should not be taken as static, and it's worth thinking about like what should this be, and also looking historically to say when things shifted the most. What were the personality characteristics behind the people who made it shift the way that it did, right? So I remember a particularly good talk that he gave where he was presenting it as if it was the 1960s and he was looking at the future of programming and talking about all the exciting things happening those days from like Licklider and like time sharing computing and like really reimagining what programming should be, and drawing the line out. And what was most like compelling about that is that he's talking about true historic things and how if you were to draw the line out, it gets you like this really wonderfully inspiring landscape for what computation could be. And what programming ended up being was a lot more linear than that. And so it's this reminder that like the future is ours to invent and it won't invent itself. Yeah, I don't know how directly I've ever like taken a concrete thing that he's like worked on or talked about and tried to incorporate it, but maybe I should. Maybe I should dive into the rabbit hole again because, yeah, that just always leaves you more inspired than when you started.
You mentioned personality characteristics. What do you think some of those are? You seem to have a real appreciation for the people who came before you to create these mathematical concepts, who extended the frontier of math. And I think that as much as any field, it requires a dogged commitment to your work and a faith that things are possible. You know, a lot of the people who have made mathematical progress were considered lunatics or outcast by society, and lunatics to themselves at times. I can only imagine the doubt and even the self-loathing of what those people must have felt, because often these problems will take 5, 10, 15 years to solve.
Well, one common misconception about mathematicians is that they're these like lone geniuses off writing sole authored papers like in their attic. And maybe this is exacerbated based on certain prominent historical figures who are not like the most social characters in the world, like Newton. But the reality of modern math is that it's heavily collaborative. I do remember when I was like in high school and I was at this like university math circles type thing where they like have a mathematician come and talk, and someone just asked, what is it about your job that you didn't expect, that kind of surprised you about being a mathematician? And his answer was, I travel a lot more than I thought I would, because you know you're in some specific discipline and you got to collaborate with other people. And so he's just like a lot of his life is spent flying off to the right people to collaborate with. And I think even now that violates what people's image of a mathematician is, that you're like seeking out the people to work with, or that I don't know, a lot of people will cite like Terry Tao as being, you know, one of the best mathematicians, living mathematicians in the world. One of the things that characterizes his work is just how much of a social butterfly he is. It's like swoops into one area, helps there, swoops into another, helps there. And it's kind of by having this super broad understanding of all the different types of math and being able to take the pieces from one and putting it into another, that seems to be what makes him such a valuable asset. And you have all sorts of characters like that. Paul Erdős is another very classic example of someone who was this itinerant, like if ideas were viruses, you know, we were describing him as like the super spreader who's like R value is through the roof. So those sort of people.
That's a great question, and I'm going to throw it right back at you. What is it about your job that you didn't expect?
Oh, well, the job, I guess. Like I don't think I would have said
The actual thing that I do of making videos about math.
You asked me like 10 years ago, like, what do you think you're going to be doing? It's not this, that's for sure. Yeah, the fact that anything that I do involves like kind of like this kind of stuff right here. I'm on a podcast, this sort of public presence, or that I'll like give public talks, or it's some of the things I'll like be on camera and like having to think about like entertainment in that way, and that's something I just would not have expected. It's not really in my personality as much. I think it took me a while to be comfortable with public speaking. I think it takes a lot of people a while because it's just not a natural thing. So that it's fun and I like it, but that was not expected or in any of the plans I had for what career trajectories were likely.
Within mathematics, what's your favorite constant? Pi, E, something like the golden ratio?
All of those are pretty terrible, to be honest. I'm a fan of one. So phi, everyone knows that's overrated. That It's just like this source of weird numerological obsession that is not born in any actual facts.
Hmm.
People look at a conch shell, they're like, it's the golden spiral. You're like, it's actually not if you do the measurements. Um, it's a solution to a particular quadratic. It's not all that special. Pi, very well reported, how it's a little bit awkward that we use pi instead of tau. It doesn't really matter. It's just like choose your favorite circle constant and move forward with it. Pi's fine, I guess. E, this one is, I think, heavily overrated because what matters is the function, this natural like exponential function, and E is just the value this function happens to have at one. Um, it's interesting that the value it has at one, like can sort of carry the weight of the function, and thinking of repeated multiplication with that value gets you a long way for what the function is about, but it doesn't get you anywhere near the full breadth of what this like deep exponential function does and relates to. And the first time people start to get a feeling of this is when you see like e to an imaginary number. And you're like, that doesn't make sense. But it goes beyond that. You see raising e to the power of like a matrix or an operator. You look through like quantum physics, and this comes up all the time. And it actually has nothing to do with the number e is the problem. It's like e was this numerical residue of this function back in the land of real numbers, but it really has nothing to do with what's going on there. So that one's not just like overrated, but I think leads to a certain category of misconceptions. So yeah, as far as like constants go, uh, one, you really can't beat one. Multiplicative identity, you keep adding it to itself and you get all the natural numbers. It's this nice like reduction homeland point. And just because it's popular doesn't mean it doesn't deserve it. It's not even popular. Just because it's well known doesn't mean it deserves all of our respect and love.
Well, if it's a stock, why is it an undervalued stock? What is it about the nature of one that makes it undervalued? I saw a book recently called Zero that came out. What's going on with one?
If it's undervalued, it's because it's like one of those backbone core of the economy, unsexy data aggregating kind of
Plumbing
companies.
company, Grant.
Yeah, right. It's not the Snapchat with the meteoric rise. It's not like the social media companies of any kinds that's like on the top of your mind because you're a consumer. It's instead like laying the fiber or something that like you just don't necessarily think about, or it's like providing oil drilling equipment. Um, it's it's core. It's like incredibly valuable. It's not that people don't think it's there. It's just that it's not attracting the same love that some of the other pop stars of the real number line around it are attracting.
You mentioned writing scripts a little while ago, and I didn't want to let go of that thread. So you have two kinds of videos: problem solving videos and expository videos. How is your script writing process different for both of those?
The level of pain, for sure. Yeah, problem solving videos are the most fun to write, and they
Easy.
write themselves because you know the end point and you know the start point. So you just have to like draw a verbal line between the two. Expository videos, it's like, what is the end point here? And what is the start point? What do people know about this topic? And like, what are we trying to say? And what are the not the perspectives that I can try to provide around it that like wouldn't be found in other expository works on this? Yeah, so that it's almost always problem solving. Sorry, the expository ones where I will try to, if I am on top of my game, will try to do sample lessons because that's where it's valuable. Actually, yeah, I probably almost never actually do a sample lesson on problem solving
Hmm.
ones. I just sort of, it's like maybe I should. That might actually make it better, but it sort of feels a lot easier to know where everyone is because basically because you're bringing in something without any priors. It's like if I ask this question that's like a probability question on a certain geometric setup, you didn't come in with pre-existing assumptions. You just came in because like you're at the same point everyone else is. The challenge that brings is that I didn't have to motivate like why we should care about this random puzzle. So maybe that's a little bit harder. Whereas exposition ones, the motivation comes pre-baked. Like I don't need to tell you to care about neural networks. We can just dive right in. Whereas if I ask you, hey, if I choose a random semicircle on a disk, like on a circle, and I keep doing that, and I count how many times does it take before the whole circle is covered, where I'm doing it with uniform probability. Like what's the expected number of times? That's a fun puzzle. I think it's fun. It's going to be a fun process to explain why it works because there's like a very clever insight that will be involved. But there's not a great way to hook you into that because it's not. uh, it's what we were talking about earlier. It doesn't have boots on the ground for touching reality. So I would happily make a video on that problem as soon as I have a good hook. But until then, it just has to kind of sit there as the script that will be easy to write one day as soon as it has a title.
Interesting. So there's something that you said there that I think that you implied that maybe you have ideas that you're just waiting to talk about until you have a hook. Do you ever have a hook without an idea?
Oh, that's a good question. None that I feel proud of, I guess. Well, oh, there was some like shamelessly clickbaity thing I was thinking of before that could make like a nice. Uh, no, yeah, none that I feel proud of. I can't think of anything because usually if you have like a hook, it's because you have some sense of what you're hooking someone into. So the only thing I can think that was like truly without substance, I'm like, man, if you had a video that just said, "Do not click this video," how many people would click it? And then like, what sort of like sociological narrative could you put around that to like fill it with content? Well, there's nothing there. That's just like to make such a video would be nothing but clickbait at that point.
Well, one of the things that I think you and I both agree on is you don't want to start a video right at the beginning of your research process. Like there's a idea that's kind of ingrained in school. It's like, okay, welcome to US history class. At the end of the semester, you're going to write a paper on the Civil War. So now is time to start researching. And then you know exactly what you're going to write. You research, research, research. But that's actually tremendously costly. What's better to do is the word that you used was ambient research. And you exist in this state where you're just interested in math. And through that process, you're researching a lot of things without even knowing it. And then one day, well, you find your hook and it all comes together. And now it's time to make the video. What is that process like for you?
It's exactly what we were talking about earlier, where that's why idleness and distraction are valuable. It's because those are like, in a sense, the ambient research phase. Um, so it looks like just reading books or being willing to get caught into a rabbit hole of an interesting question, um, and like not feeling guilty about part of the day washing away to that effect. And then just keeping notes and having a spot that I can turn to on those notes at some point. Um, it's like kind of as simple as that. And very often, if you were to actually track like where an idea came from for a video, like the seeds of it sit like years before the production process started.
What do those notes look like?
Oh, I mean, sometimes it's like literal like pad of paper and pencil just like scrapped at the side of the computer. Um, Sometimes it's just like a text editor document that's open while I'm reading something. It's probably not as organized as it should be. I've got like a long Asana list of like potential video topics, and like the detail section of each one will have a little scrapped like bullet point of important points. Yeah, it's honestly not terribly organized if I if I'm like open with you.
What percentage of your notes are drawings and visual versus text and more logical?
Honestly, actually, a lot more logical than like text. I think there's like isolated different. I'm just like calling through my notebook now. I guess drawings. I guess maybe like on the pen and paper, it's like 50% things that are like sketched in drawings, but then a lot like that's where you'll maybe like work something out. And so often if you like, let's say you want to find an intuitive explanation of something in math, often the first step is to like actually go through the non-intuitive explanation. Um, like the most recent thing that's sitting in front of me here is like trying to understand why like a binomial distribution tends to look like a Gaussian with large numbers, and just kind of like working out um, how Stirling's approximation on factorials like makes that pop out, and if there's an elegant way that it does. And in that case, I guess the central question in mind after doing that is to like look at the algebra and say, are there parts of this that felt like they must be true, um, in a way that could be like visual or could be better motivated or something like that. I don't think this particular page would ever like turn into a video, but that's yeah, that's I think kind of a valuable thing to do is to just like get into the nitty-gritty of like working it out in like the boring algebraic way so that you can assess like does it have to be as boring as it seems.
Say that you have a seesaw of universities beginning to struggle and they lose funding for mathematics departments. And so on one end, what's going down is the ability for professors to wander into what you could call matherbation and to spend time there and to just sort of think outside of the blue and spend time at these highfalutin to abstract ideas. But what you have on the flip side is the ability for people like you to use YouTube and use the internet to share ideas and to have a business model that you're actually more in control of. What do you think hurts mathematics with that outcome and what helps?
Well, yeah, I mean, I guess what you want is something that is stable and scalable for all of the like the good thinkers out there. And the university system, it's a little bit awkward, this notion that the value kind of really comes from the teaching and printing of degrees, kind of from the research too, but like that it's heavily leaning on like pumping undergrads through it. I There's a part of me that kind of hopes that industrial research um, fills that void a little bit more. I think it's healthy to have people who are otherwise very theoretical have a forcing function to make it applied. And if the way that the pure mathematician spends his time, that's not just like the ambient thinking about stuff, isn't teaching undergrads, but is like working with professionals to try to like apply his material, that actually seems pretty healthy for math as a whole. Although, of course, like asking yourself to teach something is a great way to come to new ways of understanding it. But the problem with that is it will let you get more and more distant from what matters.
Hmm.
Like if you actually experience an undergrad education in math, uh, it's not it's not at all clear how any of the stuff is used or like why the constructs are defined the way that they are. Um, it's not terribly motivated in a way that it could be, and I think that might be coming about because the people who are putting together the curricula and the books and like teaching it, the rest of their time is also like high up in the clouds, and the act of like teaching undergrads still remains in the clouds, and it's not what you described as boots on the ground. But at the same time, I just don't know how like scalable the idea of pure math research through industrial labs like actually is and how much value there is because it seemed like it took something very exceptional like Bell Labs with like this government sanctioned monopoly in order for anything like that to actually exist. And we kind of see pockets of it these days, but usually it's like statistics and machine learning research in disguise. It's not really like pure theorizing.
It feels like statistics is really like to go back to the stock. It feels like a momentum stock. Like it feels like it's gaining a lot of value and popularity very fast as opposed to say something like calculus. Like in my own life, I come across the cutting edge of statistics way more than calculus. And those were the two higher level maths that I took at the end of high school. Why do you think that is?
Well, I mean, calculus seemed to have this role in the current education system based on what engineering used to be,
Hmm.
which is much more heavily into like electrical engineering, mechanical engineering, very like physics-based topics, where the more physics-based it is, it makes sense to have a strong foundation in calculus, whereas the more data-driven it is, then by its very nature, that's more statistical. Um, so a lot of people will say that we should push down the emphasis on calculus so as to bring up the emphasis on statistics. It's not really an either or. I mean, a lot of actual stats, you do need to have some good basic calculus in order to grasp it. Just like calculus is fundamental for anything as soon as you're dealing with a continuum. Um, but that, yeah, it seems to be a reflection of what engineering looks like today versus a century ago, and how slow moving changes in education are.
You mention data, and that sort of leads me into just cutting edge technologies. You know, if you make the assertion, which I think is generally true, that one way to almost guarantee progress in a field is to create some kind of collision where you have the intersection of two different fields. And it seems like right now, one of the things that we're going to end up with is the intersection of a lot of computing power with mathematics. What do you think the implications of that are?
Do you mean implications for pure math research, or do
Yeah,
you mean how pure math gets applied to this data analytics?
the first one for pure math research.
Yeah, so I mean, I actually don't know a ton about this, but it is the case that the field of like proof checking and writing basically like programming languages to formalize math such that you could write your proof in this language and have it automatically checked, that is growing and seems to be thriving, and I think can have pretty big implications because um, certainly if you get it to the point where you can like actually democratize the writing of a theorem in a way that's checked automatically,
Hmm.
you kind of solve the crank problem, which is that if you have someone from outside academia who like writes in claiming to have a new math result, it's almost always the case that they don't, and they just don't appreciate the nuances of like why a given problem is hard. This is the sour side actually of what you opened this whole podcast with, questions about prime numbers and good unsolved problems, is that as inspiring as they are, what they end up attracting is a ton of just like the common word to use is crank papers that are just attempts to prove it that are a lot less sophisticated than what would be needed to solve it. And it's kind of a sad situation because at the same time, every now and then there is someone from outside academia who does have a meaningful result, and you don't want to just like cast all of these out. You don't want to be uninspiring. But in a world where everything's so rigorously programmable that you can just say, oh yeah, as soon as you like submit the proof in lean and the proof checker verifies it, then yeah, we'll like give it attention and like maybe invite you over. Then you would just have this like automated, non-personal process by which all of the cranks can like see that, oh, this is where the fault of the proof lay, and where people who aren't cranks and actually have like something to offer, like actually have a chance. But I think the meaningful value that will come from like proof checking extends a lot beyond just like the crank problem. It's kind of setting things on a more formal foundation. It's bringing in like artificial intelligence tactics to help find new proofs or new potential avenues towards something. I think, and like, people will talk about, oh, but these things won't be creative. That it's like a very rote exploring the decision tree of
Mm-hmm.
like ways to prove something. But any chess enthusiasts who follow AlphaGo seem to uh, agree that in very rigidly defined formal environments, you can have an element of creativity that seems to be coming from the computer. And math seems like really the lowest hanging fruit for that in a non-gamified circumstance. So that promises to be pretty interesting in the next century.
Cool. I want to ask you just a couple, just quick questions. We'll bump around for a couple minutes. The first quote, and then a couple questions just about you in particular. Here's the quote from Angus Rogers: Mathematics requires a small dose, not of genius, but of an imaginative freedom, which in a larger dose would be insanity.
Yeah. Okay, so I like that. It seems to be hitting on this idea that insights come from exploring something that no one else thought to explore because it really seemed like it wouldn't yield anything. Like, wow, you'd have to be kind of crazy to try working with this structure or to tweak the equation in this way or to um, bring in uh, this new feature to your diagram or something like that. Like it requires doing something that other people wouldn't think to do, and that there's kind of a reason they wouldn't think to do it. Um, and so that too much of that is just indistinguishable from insanity because it means completely violating like the norms and priors for what will work. Yeah, that's a very beautiful quote.
That's from one of your videos. It's from the
Wait,
series
what?
on linear algebra. You're saying it like, I don't know it. And I was like, well,
Oh,
I got another quote for you from one of your
why?
videos.
That's so funny.
Well, it's fun
That was
because I,
4 years ago. I can't remember what I put in
yeah,
a
I
video
know.
four
Well, it's
years
fun.
ago.
And look, that's the benefit of creating online, right? You can create something years ago, and I could just go on and watch with a whole fresh mind. It exists forever. Okay, one more from that same series. Unfortunately, no one can be told what the Matrix is. You have to see it for yourself.
Oh yeah, that was fun. Yeah, I just thought that was like a wonderful, that one I do remember including because like the whole theme of that series was that to think about matrices, you should visualize them, and there's a specific way to visualize them, and that you have this like famous thing from Sinnoh where Morpheus is saying you have to see it for yourself. Like that just, I mean, come on, the parallel's too strong not to lean into.
Yeah.
A lot of that is true. I think like this is the central theme of the whole channel. For everything else that we talked about, like the actual reason I think a lot of people are engaged is because it centers on visuals, and we're very visual thinkers, and a ton of just like a ton of the mass of our brains goes towards visual processing in contrast to processing other raw sensory information. And I think that it's almost like you're leveraging more computation, and through that, it means that you've like opened up the scope of what people can have intuitions for.
Oh man, that is a really interesting point. I mean, I think that there's something even further that's going on is it's the motion of visuals and the way that math moves in your videos that creates an element of resonance.
Yeah, I mean, I guess that's sort of maybe because it feels different than reading a textbook, and that's the thing that most highlights the fact that it's not the way that you've been experiencing math through school is the like dynamic nature to it. I'm not entirely, despite what I do for a living, I'm not entirely sold that the movement matters that much for the intuitions.
Hmm. I think that the movement matters because, well, I mean, it obviously depends on the video, but I think that it matters the most when you just have to see how things are represented. For example, you talked about the boxes and how the boxes hit each other, and then the boxes hitting each other equals pi, and the and then when you sort of rotated the sphere in that video, I think that it's sort of unforgettable in a way, and the unforgettable nature of it sort of makes it sticky in my head. How much do you think of yourself as teaching math versus popularizing math versus inspiring people to learn math on their own?
Oh yeah, three different angles. I mean, so when it comes to teaching, I think to gain a new understanding of something, it has to be information flowing from inside your head to out of it, not the other way around.
Hmm.
So you can't have someone come and like pour knowledge into your head. Instead, they have to evoke it out. And in fact, the word education has its root in has the same root as the word educe, like to bring out. You kind of follow the etymology tree, and I think there's no coincidence there. It's this very Socratic idea, and so in that way, the default for any video or any lecture or any book is that it's not like teaching, but that's a little too easy to say because really it's like it is quite possible for a piece of text or for a lecture to evoke something to bring it out of someone. So if there is teaching that happens, it's only because of that. The truth is, though, the actual value add I think lies almost entirely on the inspiration half, for like getting someone to feel that math is something that they like, that they can understand, that's worth pursuing further, that they can self-identify with, that can be part of their personality, all of that. In order for that to work, though, you can't just inspire by like saying inspirational words around it. You have to give an actual lesson. You have to give, if not understanding, at least the illusion of understanding in a moment for that inspiration to have any kind of teeth to it. So most of the effort is still going to be around making something understandable, being as clear as you can, finding the elucidating visual, all of that, even if the end goal and the actual mechanism of value add comes from inspiration and not from what will this person be able to recall a few months later.
That's a beautiful place to close. Grant, thank you very much.
Hey, thanks for having me on. This is fun.